turned on.
Wait. So, on this paper,
Yes.
it needs to line up, like everything line up? What does it mean by 5?
Let's see here. So they'll be the same at 5 lines. So it was asking who is cheaper per line. So Greenville was cheaper per line because they charged 2 instead of 3.
Yeah.
And at 5 lines, the cost to run an article for Greenville will be the same cost as Daily Times.
For 5 lines too?
Yep. So it was asking for who is cheaper, how many lines must for them to be the same. That was it. Yeah, so.
Because they were just the first, they were both 24. That's why I thought they'd be the same.
Yep, so at 5 lines, they'd be equal. I can look back at the equations and see what happened here in a bit.
Literally every single one of us, except for Braxton.
Oh, that's a 7.
170, yeah.
So we're all watching the fire. He's like this. Literally the whole time. I was on the table.
All right, guys, so what we're doing today, are you ready for it?
Yeah.
Adding and subtracting matrices. To be able to add or subtract 2 matrices, the dimensions have to be the same. If the dimensions are the same, we add or subtract the corresponding elements. The sum or difference of 2 matrices with different dimensions is undefined. It's not possible. Let's see how this works. So if we look at these first 2 matrices here, the first one is a 2 by 2. The second one is the dimensions are the same, so we add the corresponding elements because we have a plus in the middle. So 2 and 1 are corresponding elements. They're both in the top left. So we would say 2 plus 1. Negative 1 and 2 are corresponding elements. So we would be adding them. 3 and 4. And lastly, 0 and -2. Since we have the same dimensions, we're adding the corresponding elements. So 2 and 1, negative 1 and 2, 3 and 4, 0 and -2. Questions on this so far? 2 plus 1 is 3. Negative 1 plus 2 is 1. 3 plus 4, 0 minus 2, or 0 plus -2. That's it. Questions on this here? Now, you don't have to write out the 2 plus 1, negative 1 plus 2, all of that out. We could just go, so 2 plus 1 is 3. Negative 1 plus 2 is 1. We could just add them. If writing it out helps you see it, write it out. We ready for the next one? So the first one's dimensions are 3 by 2. The second one is a 3 by 2, so we're good there, yes? So we can subtract because it told us to subtract. So we'd have 2 minus negative 1. Negative 3 minus 2. Five minus 7. 4 minus 8. Negative 2 minus negative 5. 8 minus 6. Since we were subtracting or had subtraction between them, we're subtracting the corresponding elements. Two minus negative 1 is 3, because our negative makes a plus. Negative 3 minus 2, negative 5. 5 minus 7 is negative 2. 4 minus 8, negative 4. Negative 2 minus negative 5, well, the negative makes a plus. Negative 2 plus 5 is 3. And lastly, 8 minus 6. Questions on this here? Now, yes, we could do this in the graphing calculator. Graphing calculators can do matrices. To do that, the first thing we're going to have to do is input the two matrices in. So we go second matrix over to edit. We have to tell them that the first matrix is a 3 by 2. And we'll put it in. So 2, negative 3, 5, 4, negative 2, 8. We get the first one plugged in. We have to go second quick. Second matrix over to edit. This time we're going to B because I have two matrices we're adding together. It is also a 3 by 2. Negative 1, 2, 7, 8, then negative 5, 6. So we did all that to put A and B into the matrices. A went first, so when we go to actually do the operation, we call A first, and we're subtracting from it matrix B. We get the exact same matrix, yes? See here, probably typed it in. 2 minus negative 1 is 3, negative 5, negative 2, negative 4, 3, 2. Yep. Same matrix, yes? We have done that faster by hand than typing that thing in. Yeah. So sometimes the graphing calculator can do stuff, but we can actually do it faster than it would be for it to do it. Questions on this here? We feel good with these here? I mean, this here we're just adding, yes? So negative 8 plus 6 is what? Negative 8 plus 6? Negative 2. 1 plus negative 1? 0. 3 plus? What are our dimensions of the two matrices? So the first one is a 2 by 3. The second is a, so this is undefined. It is not. We can only add or subtract matrices if the dimensions are the same. And I like going through this and not just immediately saying not possible. Because if we notice, there is nothing for us to add to the 3. It has no corresponding element. It feels like we should be able to just put a 0 in that spot and be good. But by doing that, we change the second matrix. We change what it is. It's no longer a 2 by 2. It's now a 2 by 3. Those are not the same thing. It's just not possible. Interestingly enough, we would not say that this is no solution. Because we're not solving for anything, we're performing the operation. No solution is when we're actually solving. If this is just not possible, it's undefined. We good with this here? I'll do 3 more of these. This one here, we do have a 2 by 2 and a 2 by 2. So we can't add these together, yes? So we'd have negative 1 plus 6, 7 plus negative 4, 5 plus negative 8, 3 plus 2. Negative 1 plus 6 is 5. 7 plus negative 4 is 3. 5 plus negative 8, 5 minus 8 would be negative 3. And 3 plus 2 is 5. Already got B done? Yeah. Ready to look at the next one? Other way. Need to go back?
I think it's good.
Yeah. No, you're fine.
Oh,
2 minus negative 3. Well, the negative and negative would make a 2 plus 3. 5 minus 0. Especially the double negatives. If writing those out helps keep that straight, write it out. If you're able to keep it straight and go straight from 2 minus negative 3 to 5, do that. Or we can just type it in the calculator, 2 minus negative 3. 30xs will do that just fine. Questions on this here? This one is not possible because we have a 2 by 1 and a 1 by 2. Not possible. We cannot add or subtract two matrices with different dimensions. Dimensions, when we add or subtract, have to be the same. Interestingly enough, we'll not get to it in this chapter, but we can actually multiply these two together. Dimensions for matrices when multiplying do not have to be the exact same. We will cover that later. Be ready for the next piece. Scalar multiplication. We can scale a matrix. We can scale it up. We can make the numbers bigger. We can make them smaller. Whenever we scale something, we take whatever the number in front of it is and multiply every element in that matrix by it. So let's see what that actually means. So when we have this one here, we have 2 times the matrix. So what we're going to do is we're going to take every element in this matrix and multiply it by 2. So we would have 2 times 3. 2 times negative 2. 2 times 1. 2 times 5. 2 times 2 and 2 times 0. So when we scale it, we're just multiplying every element, every number in the matrix by that amount. Interestingly enough, we cannot divide matrices, but we can multiply them by fractions. So if we want to scale it down, we'd multiply by, say, 1/2, 1/4. We can multiply it by a fraction. We can have fractions in matrices. 2 times 3, 6. 2 times negative 2, negative 4. 3 times 1 is 2. 2 times 5 is 10. 2 times 2 is 4. 2 times 0 is 0. This is it here. Questions on this here? I know 3 of y'all are in academics. Academics, the way we have to read these, or especially if you did this and have to read the answer out, is very time consuming. Because especially the way you would read this is top row left to right, 6, negative 4. Second row left to right, 2, 10. Bottom row left to right, 4, 0. So you kind of have to specify what you're talking about. Right. Questions on scalars? Do we feel comfortable with scalars? All right, we'll move on. We're going to combine what we've done so far. We're going to scale and add together. Whenever we have this here, we multiply by the scalar first and then add or subtract next. Now, since the negative 3 is only in front of that first matrix, it only applies to that first matrix. So we're going to say negative 3 times 5, negative 3 times 0, negative 3 times negative 2, and negative 3 times 4. The second matrix C is still negative 1, 7, 3, 2. I can show you here exactly how we would know if it needed to be applied to both. Is if those two matrices are inside parentheses. Then it's saying that that negative 3 is being applied through the matrix or through both. At that point, again, order of operation, let's do what's inside the parentheses first. Let's add them and then multiply the result by negative 3. But we don't have parentheses. Questions on how we got here? So the first matrix C would be negative 15, 0, 6, negative 12. Now we can just add. We'd have negative 15 plus negative 1, 0 plus 7, 6 plus 3, negative 12 plus 2, or we could have just written negative 16, 7, 9, negative 10. Same thing, yes? Yeah. Matrices do show up every now and then on the ACT. Questions on this here? I think one more would be good, because I think y'all pretty much got the hang of this, yes? I'm going to throw in a specific case. We're going to look at number 6, but I want you to change it slightly. Other side. There we go. I want to add a number. I want to add a scalar with it. So we're just adding the number 3 there. Now multiplying the first one by 4 is exactly what we've been doing. 4 times 3, 4 times 5, 4 times 4, 4 times 2, 4 times 0, 4 times negative 2. Now the question is, for the other matrix C, do we multiply by positive 3 or negative 3? And the answer to that is yes. It does not matter which we do. If we multiply through by 3, so 3 times 9, 3 times 7, there we go, 3 times negative 6, 3 times 5, 3 times 2, and 3 times negative 3. We can do that product of 3. The sign between them stays negative. We are just taking the 3, we're not taking the negative with it, so we're still subtracting. However, we can take the negative with it, because if we multiply by negative 3 instead of positive 3, we're not subtracting anymore. What would we do? We'd add, because we took the negative with it, so now we're going to add the 2. So we'll do it with plus. We'll multiply through by positive 3. I will show you what happens in a second if we did negative 3. Because if we do this product, well, we can multiply here first. 4 times 3 is 12. 4 times 5 is 20. 4 times 4 is 16. 4 times 2 is 8. 4 times 0 is 0. 4 times negative 2 is negative 8. Minus 3 times 9 is 27. 3 times 7 is 21. 3 times negative 6, negative 18. 3 times 5 is 15. 3 times 2 is 6. 3 times negative 3 would be negative 9. We good so far? Then the last thing we need to do is to subtract. 12 minus 27, 20 minus 21, 16 minus negative 18, 8 minus 15, 0 minus 6, negative 8 minus negative 9. We good? Yeah. Okay. Because 12 minus 27 would be negative 15. 20 minus 21 is negative 1. 16 minus negative 18. Well, the negative and negative would make a positive. So 16 plus 18 is 34. 8 minus 15 is negative 7. 0 minus 6 is negative 6. Negative 8 minus negative 9. Well, again, the negative and negative would make a positive. Negative 8 plus 9 is 1. So we feel comfortable with this here, yes? All right, you do not have to rewrite this. But if, let's just say, I said instead of multiplying by positive 3, I multiplied everything by negative 3. Let's see what changes. 27 would now be negative. 21 would also be negative. 18 is now positive, 15 is negative, 6 is negative, 9 is positive. And the sign between them is now plus. So now what we're looking at is not 12 minus 27, but we're doing 12 plus negative 27. Well, 12 plus negative 27 is the same as 12 minus 27, yes? Still the same thing. 20 plus negative 21. That's still 20 minus 21, yes? So now we have 16 plus positive 18. 16 plus 18. 8 plus negative 15. 0 plus negative 6. And we have negative 8 plus 9. So did it really matter if we multiplied by 3 or negative 3? No, it just changed kind of how it looked. We still get to the same spot. If you feel more comfortable multiplying by the positive 3, do positive 3. If you're fine like doing the negative 3 version, do the negative 3. Either will work. Questions on any of this here? That's it. That is all we have for 1.7. 4 through 8, all. 7 and 8. 7 and 8, the students' work for that there, or the work that they gave you for it, is wrong. They did not add the two matrices correctly. So you need to say what the correct sum of those two matrices is, and then state in your own words kind of what they did wrong. 9 through 21 odd, perform the indicated operations. If you notice on 17, 19, and 21, they defined what A, B, and C are up top. You're just using those matrices for each one. Yes, sir. 7 and 8. Because if it has that big X next to it, that's the error detection, error analysis. So you have to say what they did wrong, or kind of in your own words. I'm not looking for specific wording, just are you describing what happened, what they didn't, and then writing down what the correct answer is. So the error analysis should have two parts. The correct answer and kind of describing the error. You're welcome.
So, like can we, do we have to put this down on a paper, or can we just put the answer down?
Oh yeah, you can put the answer down.
Okay.
Yeah, I was writing it out for y'all so that you can see kind of what's going on.
Yeah.
But 4 plus, you can just put 10
Yeah,
to start with.
wanted us to like show over.
This here, it's neither here nor there. But especially in like the systems of equations, if you're writing that one out, it's nice to see the steps. So if you do get a wrong answer, I can go back and find where that happened. That way you can see it and kind of compare and contrast. 1.7 is the last section in chapter 1. We are finished with chapter 1. Monday is a makeup day. You will have the entire class period to work on any of your missing assignments. Tuesday, I will give you a review sheet. You have the entire class period to work on it. Wednesday, we'll go over it. Thursday's part 1 of the test. Friday is part 2. I cut it into 2 parts to make sure you have more than enough time to finish it. But we are done with chapter 1.